Have you ever found yourself gazing up at the night sky, pondering what will happen to the universe in the end? It's a question as old as humanity itself, and one that has sparked countless debates among scientists, philosophers, and stargazers alike. We're on a cosmic journey today, a journey that begs the question, what is the ultimate fate of the universe? Is it destined for a fiery collapse, a chilling standstill, or something entirely different? There's no shortage of theories on this topic, each one more intriguing than the last. From the Big Crunch to the Big Freeze, from the Big Rip to the concept of a multiverse, we'll delve into them all. We'll explore the reasoning behind these theories and the evidence that supports or contradicts them. So, buckle up as we dive into the cosmos and explore the theories that scientists have proposed about the future of our universe. Imagine if everything you see in the universe today was to start contracting instead of expanding. It's a mind-bending concept, right? This is the premise of the Big Crunch theory, one of the many proposed answers to the ultimate fate of the universe. The Big Crunch theory is the antithesis of the Big Bang. You know, the event that kicked off the universe some 14 billion years ago, expanding a singularity into everything we see today. So, what if that process could be reversed? What if all the galaxies, stars, and space itself started to shrink back down, compressing into the same single point from which it all started? That's the Big Crunch theory in a nutshell. It's a scenario where the universe's expansion, fueled by the mysterious force known as dark energy, eventually slows down. Gravity, that unyielding force that keeps your feet on the ground and the planets in their orbits, would then take over as the dominant force. The universe's expansion would not just stop, but reverse. Everything would begin to collapse in on itself. Imagine the galaxies spiraling inwards, stars and planets drawing closer together. The sky would become a dazzling, terrifying display of celestial bodies hurtling towards each other. Eventually, all matter would converge into a single, infinitely dense point, a singularity. The universe as we know it would cease to exist, replaced by an unimaginable concentration of energy and matter. Now, it's important to note that the Big Crunch is just a theory. It's one of several possibilities for the end of the universe, and it's based on certain assumptions about the nature of dark energy and the universe's overall density. If these assumptions don't hold up, the Big Crunch may not happen at all. But isn't it fascinating to think about? The universe, born from a single point of infinite density, might return to that same state, like a cosmic snake eating its own tail. That's the Big Crunch theory for you, and end as explosive as the beginning. Now, what if we told you that the universe could just keep expanding forever, growing colder and darker with time? This is the premise of the Big Freeze theory, one of the most widely accepted hypotheses about the ultimate fate of the universe. The Big Freeze, also known as heat death, suggests that the universe will continue to expand indefinitely until it becomes too cold and sparse to sustain life. To understand this concept, let's break it down a bit. Currently, we live in a universe that is expanding. Galaxies are moving away from each other, and the space between them is growing. However, the rate of this expansion is not constant. It's accelerating, thanks to a mysterious force we call dark energy. As the universe expands and accelerates, the energy density of the universe decreases. This is because the amount of energy in the universe is finite, but the space it has to fill is continually growing. Over trillions and trillions of years, the energy density of the universe will approach absolute zero. When this happens, the universe becomes a cold, dark, and desolate place. Stars will burn out, galaxies will drift apart, and eventually even the smallest particles will decay. This is the Big Freeze. And what's even more chilling is the timeline. If the Big Freeze theory holds true, we're looking at an end that's unimaginably distant. We're talking about a timescale so vast that it dwarfs the current age of the universe, which is a mere 13.8 billion years. But before you start panicking, remember that this is just a theory. There's still a lot we don't know about the universe and its ultimate fate. The Big Freeze is based on our current understanding of the cosmos, and as we've seen time and time again, our understanding can and does change. So, while the Big Freeze paints a bleak picture of a universe slowly fading into darkness, it's not the only possible ending. There are other theories out there, each with their own unique take on the final act of our cosmic drama. That's the Big Freeze theory, a chilling end to everything we know. Now, brace yourself for a more dramatic ending. What if everything in the universe, right down to the smallest particles, was torn apart? Welcome to the world of the Big Rip theory. This theory posits a universe that not only expands, but does so at an ever-accelerating pace. Imagine a universe that is like a runaway train, gaining speed with every passing moment. But what could possibly power such an expansion? Enter dark energy, the mysterious force that's believed to be driving the accelerating expansion of our universe. The Big Rip theory is based on the idea that this dark energy could become stronger over time. If this happens, the gravitational forces that hold galaxies, stars, planets, and even atoms together would be overcome by the relentless expansion. Now picture the Milky Way. In this scenario, galaxies would be the first to go. As the universe expands faster and faster, the gravitational bonds between galaxies would be broken, causing them to drift apart into the increasing void. But the destruction wouldn't stop there. Next, the individual galaxies themselves would be torn apart. Then, as the dark energy becomes even stronger, solar systems, stars, and planets would also be ripped apart. In the final moments, everything down to the smallest particles would be shredded into oblivion. But don't start panicking just yet. For one, we're talking about a time frame of tens of billions of years in the future. Moreover, this theory is based on a specific form of dark energy called phantom energy, whose existence is still purely hypothetical. Nevertheless, the Big Rip theory provides an intriguing, if somewhat unsettling, answer to the question of the universe's ultimate fate. It's a reminder of just how little we truly understand about the cosmos and the forces at play within it. So, in the grand scheme of things, the Big Rip theory paints a picture of a universe that doesn't just fade out, but goes out with a bang, or rather, a rip. That's the Big Rip theory, a finale as dramatic as it sounds. Finally, what if our universe is just one of many universes, each with its own destiny? This brings us to the fascinating theory of the multiverse. The idea is mind-boggling, yet it's one that some physicists seriously entertain. The multiverse theory proposes that our universe is just one of a potentially infinite number of universes. Imagine it like a cosmic quilt, each patch being a universe with its own set of laws and properties. But how would such a multiverse come to be? One possibility comes from the concept of cosmic inflation, a period of rapid expansion that occurred moments after the Big Bang. According to this idea, different regions of space-time could have inflated at different rates, giving birth to separate bubble universes. Another possibility comes from the realm of quantum mechanics. In this interpretation, known as the many worlds theory, every quantum event that could possibly happen does happen in its own separate universe. This means that for every decision you make, there could be another universe where you made a different choice. Now, what about the fate of these multiple universes? Well, that's where things get really interesting. Each universe could have a different fate depending on its unique physical properties. Some might end in a big crunch, others in a big freeze or a big rip, and some universes might just go on forever. Of course, the multiverse theory is highly speculative and not without its critics, but it's a concept that continues to intrigue scientists and laypeople alike. For if it's true, it means that our universe, with all its vastness and complexity, is just one tiny patch in a grand cosmic quilt of existence. And if that's not enough to blow your mind, consider this. If there are indeed an infinite number of universes, then everything that could possibly happen has happened somewhere. That's right. Somewhere out there in the multiverse, every single possibility is playing out. That's the multiverse theory, a concept that opens up infinite possibilities. So, we have these four theories, each painting a different picture of the universe's future. But how do they stack up against each other? Let's start with the Big Crunch theory. This theory suggests that the universe will eventually stop expanding and begin to contract, leading to a fiery and dramatic end. The evidence supporting this theory primarily stems from observations of gravitational forces and the concept of a closed universe. However, recent data on the accelerated expansion of the universe cast doubt on this possibility. The unanswered question for this theory is whether the universe has enough mass to reverse its expansion. Next up is the Big Freeze theory, which posits a much colder end. As the universe continues to expand, stars will burn out, leaving a cold, dark, and lifeless universe. The evidence for this theory lies in observations of the universe's continued expansion and the second law of thermodynamics, which states that the universe is gradually moving towards a state of maximum entropy. The lingering question for this theory is whether dark energy, the force driving the universe's expansion, will remain constant. The third contender is the Big Rip theory. This theory suggests that the expansion of the universe will continue to accelerate until everything, from galaxies and stars to atoms themselves, is torn apart. The evidence for this theory comes from observations of distant supernovae and the behavior of dark energy. The unanswered question here is the nature of dark energy and whether it can change over time. Finally, we have the multiverse theory. This theory proposes that our universe is just one of an infinite number of universes, each with different physical laws. The evidence for this theory is somewhat indirect, stemming from the principles of quantum mechanics and the concept of cosmic inflation. However, the main challenge for this theory is that it's currently impossible to directly observe these other universes, leaving many questions unanswered. As you can see, each theory presents a fascinating and somewhat unsettling vision of the universe's future. They each have compelling evidence supporting them, but also significant questions that remain unanswered. None of them can yet be declared the definitive answer. But that's the beauty of science. It's a never-ending quest for knowledge, a journey that takes us to the very edges of our understanding and then pushes us to go even further. It's a process of constant questioning, testing, and refining, always striving for a deeper understanding of the universe and our place in it. So, while we may not yet know the ultimate fate of our universe, we can take comfort in the fact that we're part of a species that's curious enough to ask the question and intelligent enough to seek the answer. And who knows? Maybe one day we'll find it. Each theory has its strengths and weaknesses, and science continues to search for the ultimate answer. So there we have it, 4 theories about the ultimate fate of the universe. Diving deep into the cosmos, we've unearthed the possibility of a big crunch where gravity could reverse the universe's expansion, pulling everything back into a singularity. It's a theory that paints a picture of a cyclical universe, one that expands and contracts in a never-ending loop. But, like all theories, it grapples with its own set of questions and uncertainties. Then, there's the chilling prospect of the Big Freeze, which speculates that the universe will continue to expand, stretching galaxies farther and farther apart. As stars burn out and new ones cease to form, the universe could become a cold, dark, and desolate expanse. It's a slow march towards entropy, the ultimate equalizer where all energy is evenly distributed and nothing new can form. On the more dramatic side of the spectrum, we have the Big Rip. This theory suggests that dark energy could become so potent that it tears apart everything in the universe, right down to the fabric of space and time itself. It's a cataclysmic end where not even the smallest particles could escape the destructive force of expansion. Last but not least, we've explored the intriguing concept of a multiverse. This theory posits that our universe is merely one among an infinite number of universes, each with its own laws of physics. If true, then the fate of our universe might just be a small chapter in a much larger cosmic story. Each theory, with its own unique set of predictions and challenges, offers a different lens through which to view the universe. They are the result of our relentless human curiosity, our desire to understand the world around us, and our place within it. Even if we may never know the exact fate of our universe within our lifetime, these theories provide us with a framework to explore, to question, and to dream. While the journey towards understanding the ultimate fate of the universe is filled with complexities and uncertainties, it's a journey that tests the boundaries of our knowledge and imagination. It's a journey that makes us realize that we are part of a larger cosmic narrative, bound by the laws of time and space, yet capable of transcending them through our quest for knowledge. In the grand scheme of things, our existence may seem insignificant, but our quest to decipher the cosmos is anything but. It's a testament to our collective spirit of exploration and discovery, a spirit that has propelled us from gazing at the stars to unraveling the mysteries of the universe. While we may not know the exact fate of our universe, the journey of discovering and understanding it is an adventure that makes us all cosmic explorers. Until next time, keep looking up and wondering. Who knows? The answer might just be written in the stars. Before we wrap up our cosmic journey, we'd like to remind you that you too can be a part of this incredible exploration. If you learned something new today, please hit that like button and share your newfound knowledge in the comments below. By liking this video, you're helping us reach more curious minds like yours, and together we can unravel more cosmic mysteries. We'd love to hear your thoughts, questions, or even your own theories. Don't forget to keep up with our explorations into the enigmatic cosmos. Please consider sharing this video with your friends, family, and fellow stargazers. Remember, every interaction brings us one step closer to understanding our universe. Let's continue this journey together, fellow cosmic explorers. Our next adventure, keep looking up, keep wondering, and most importantly, keep exploring.